Hello everyone. In this video I will explain the importance of correct fuse placement in an as easy to understand way as I can. I've noticed that there are some misunderstandings about the purpose of a DC fuse during my design of electrical subsystems for vehicles where the customers indicate that they needed more information to correctly understand the fuse placement. Therefore, I will cover that topic in this video to provide a better understanding of what we are trying to do when we insert a DC fuse on a line. When will a fuse come in handy? The fuses we'll talk about today are protection devices against faults, and this is where the first misunderstanding comes forward. What is a fault exactly? People seem to think that by a fault it is meant that there is something wrong within a device or a consumer or an electrical load in general, which causes an internal short circuit inside the device, and therefore it doesn't matter where on the line you place the fuse. This is indeed a type of fault, but it's not really the primary fault we are trying to protect against here. By the way, in many cases, a device will already have a fuse installed internally to protect against these types of faults. So what do we need another fuse for then? Fuses cost money, they take time to install, they take space in the vehicle, and they actually cause a small point of resistance in the line, which is not electrically beneficial for certain loads, such as an inverter, for example. So myself, I also want to install the least amount of fuses as are required in a system. The reason we need a fuse is to protect the cable from fault currents. Why could the cable form a problem, you might ask? Well, to understand that, it's important to know how many vehicles are set up electromechanically. It is common that the vehicle's chassis is used as a ground potential of the electrical system, so this means that there is an electrical connection made between the battery negative pole and the chassis. You can see it electrically shown here. This means that any bare contact holding a potential different from the ground voltage will cause a fault if they come into contact with the chassis. An easy to understand example is if an untied wrench falls on a bare bus bar and the chassis at the same time. A short circuit is formed between the point of contact all the way back to the source. To keep it simple, in this video we will define the source as a component that can provide the highest peak power to the system. Here that is the battery. For example, it could be a lithium battery in a vehicle like this. Another example is a poorly installed cable rubbing against the chassis until the insulation wears completely off and the bare copper wire touches the chassis, again causing a short circuit. This shows us that the electrical fault current doesn't always go through the entire wire, which brings us to the correct placement of our protective devices, which is as close to the source or the beginning of each downstream wire as possible, making the unfused contact area as small as physically possible and maximizing the protected area. This will ensure that the fault current will go through the protective fuse on the exact line where the fault occurred, which also makes it easier to detect the exact location where the fault occurred and to diagnose a problem, which in our case was the wrench that fell on the bus bar. And to locate it, you look after the blown fuse and before the intact fuses. Here, the main fuse on the battery would have blown, and the other fuses on the DC loads would have remained intact. This concludes this video. I hope you found this useful. If you have any questions or you would like us to design an electrical system for your vehicle or off-grid project, the best way is to go to our website in the description and to contact us through there. We design customized Victron energy systems, complete with a principle drawing so you can get started easily with your own project. Thanks for watching. Be sure to subscribe if these systems are of interest to you, and I will see you in the next video. Bye.